Okay, we're going to do a little bit of review on 6.1-6.3. This is just solving a system of equations. I'm using 3 different methods. So let's first look at our graphing one. Our graphing method is utilizing our equation of y equals mx plus b, our slope-intercept form. And if you can turn your equations into slope-intercept form, then you can plot them quickly and easily. Like for the first one here, I'm going to subtract both sides by x. And I end up with negative y equals negative x plus 3. And then I'm going to go ahead and multiply everything by negative 1, so I end up with y equals x minus 3. So I have my y-intercept of negative 3, so I can just plot that. And my slope is 1, so it's rise 1, run 1. Rise 1, run 1. So my slope is 1, 1. So there's my line. And you'd use a straight edge to plot that point. The second one is going to be this equations right here, and I'm going to go ahead and subtract x from both sides, so I end up with negative 2y equals negative x plus 3. I'm going to divide everything by negative 2 so I can isolate y. So I end up with y equals negative divided by negative will be positive. This actually ends up being 1/2 x, or x over 2. Means the same thing, and that's minus 3/2, which is 1.5. So negative 1.5 is going to be right there. And my slope is 1 over 2. So I rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Okay? Run 2. Okay. So here is my line. And it looks like my intersection is going to be right here at that point. My intersection is going to be at 3, 0. Why don't you try that for number 2? I'm going to press pause and let's see how it works. All right, so when I plot these guys out here and I move things around so I get to my y equals mx plus b, I can see that I plot my point at 4 and I run my slope of 3 over 1, and I'll get my blue line. For my next one, I moved everything around and I end up with y equals 3x, and my y-intercept is at 0 because I'm not adding or subtracting anything. And my slope is rise 3, run 1, and that's shown at the red line. Well, one thing that's interesting here is I can see that my slope is 3 and my slope is 3, so these will be parallel, which means these are going to be infinitely many solutions on this guy. Ooh, these lines are never going to cross. Infinite is designed for if they are the exact same line. These guys are never going to meet, so there is no solution on this one. So I would write no solution on this one because they are parallel lines. All right, for the number 3, why don't you go ahead and try it? I'll press pause. For number 3, I found out that these are the same line, exact same line, so it's going to be infinite number of solutions. All right, take a try at number 4. All right, when I plot these two out, I see that they intersect at negative 1, 2. So that has exactly one solution. All right, substitution. This one is a little bit of a longer process, but it's still a really good one. I'll do number 5 with you real quick. So number 5, I'm going to take the first equation here, and I'm going to isolate the x. So I'm going to subtract 5y from both sides. So I end up with x equals negative 5y plus 4. And now that I know what x is, I'm going to substitute it in here. So 3 times negative 5y plus 4 plus 15y equals negative 1. I need to distribute this out to everything, so 3 times everything inside the parentheses, so I end up with negative 15y plus 12 plus 15y equals negative 1. I'm going to combine like terms, and I see my variables cancel out, and I end up with 12 equals negative 1. And when I see this, 12 will never equal negative 1, so I can already tell this is my proof that there is no solution. So I'm looking for things like that. If it actually equaled something, then I'd have to substitute it out. All right, why don't you try number 6? All right, when I substitute it in, I see that I get to 20 equals 20. You might end up with something else, equaling something else, because there's a few different ways to solve this. But when you end up solving them and they equal the same thing, then you know that you're looking at the same line. There's an infinite number of solutions that work for this. All right, try number 7. All right, when I did a lot of math on this guy, but and then you could have done a different way. A lot of different ways to do this. I end up with y equals -1. I substituted back in and found that x equals 12. So this is one solution, and it's at 12, -1. All right, press pause. I'm going to press pause, but you try number 8. All right, when I work this out, I see that number 8 actually has an intersection of these two equations, and it's at 1, -4. I solve for x, substituted in, and found y. All right, this one's using elimination, using multiplication, so that means I'm going to change one of the equations so I can eliminate something. And again, you can do it adding or subtracting. Oh, this one, yeah, I'm going to do it that way, but I'm going to have to do some multiplying first. So when I look at number 9, I can change my x's, but that means I'm going to have to multiply the top by 5 and the bottom by 7 to get them the same. So what I'm going to do is I'm going to change my top equation, and I'm going to multiply everything by -2. Because I want to change this 4 into a -8. So when I add them together, they cancel out. So when I multiply everything by -2, I end up with -14x minus 8y equals 8. And now I can add them together. So I'm going to look at these two equations here. So 5x plus a -14x, I end up with -9x. The 8's actually cancel out, and I'm left with 36. Divide both sides by -9, and I see that x equals 4. Now that I know what x equals, I can substitute it in to any of these equations. I'll try it on this guy. So 5 times 4, yep, plus 8y equals 28. I end up with 20 plus 8y equals 28. I subtract 20 from both sides, and I end up with 8y equals 8. Divide everything by 8, and I end up with y equals 1. So I know that this has one solution, and is at 4, 1. All right, why don't you try it for number 10? All right, now again, you can change any equation that you want, just as long as you do it to the whole thing. But I distribute out a -2 to the second equation, and I ran it through and found out that x equals -1. And I substituted in, and again, you can substitute it in anywhere. I solve for the y, and I got one solution of -1, -5. Why don't you try number 11? All right, for number 11, I had to change both equations. I multiplied my top equations by +3 and multiplied my bottom equation by -5, thus allowing me to cancel out the 15x's. And then I just found my y. I used the y to find my x. I found out these do intersect at one coordinate at -2, 0. All right, I hope this helped out. Keep practicing. It's the only way to get good at this stuff.